We're back now with flight enthusiast Paul Glenshaw. And Paul, you brought with you a bike similar to the one the Bright Brothers used.
That's right.
And the Bright Brothers made a plane that was very organic, synergistic, very together, but they solved problems, math problems in particular, one at a time. How did they use this bike to solve a math problem?
Well, you have to imagine kind of unusual circumstances for solving a math problem involving riding down West 7th Street in Dayton, Ohio with this bike with these wheel in front of you and big plates swinging around and trying to dodge the potholes, and at the same time they're thinking about aerodynamics and angles and ratios and all sorts of things.
Well, what are those steel plates used for?
Well, just as you were talking about before, the four forces of flight, they were investigating lift and drag. And as Margie mentioned earlier, when you have your hand out the window and you feel that force against it, well, that's what this plate does. This is just a plain old flat rectangular plate that when they rode down the street was set at a 90-degree angle to the oncoming wind as they rode along. And this plate created drag.
Mm-hmm.
And because it was mounted on a rotating wheel, it would rotate the wheel this way.
Now, and I know you're going to tell us what that plate is for, but how did they figure out how to do this? Did they have some type of a guide?
Well, they absolutely did. What they were doing is they were actually at a point where they were having a lot of trouble. Before they built the Flyer, the powered flying machine, they built gliders. And their first two gliders did not fly very well at all. And they were working on data that had been mathematical numbers that had been put together about how wings work by other people.
Now, I understand there's math tables that they use, but I don't understand really what are math tables, Margie?
Math tables. Well, back in the 1800s and early 1900s, we didn't have calculators and we didn't have computers. So rather than doing all the math yourself, you would go and use the research that someone else did. So people who were experimenting with different concepts and doing all of the math would publish those as tables. Just like today, if you want to learn about chimpanzees, you don't go out and get a chimpanzee, you go look it up in an encyclopedia.
So they used some math tables, but did those math tables, did they work? Were they okay?
Well, the math tables were as good as far as they went, but the Wright brothers built gliders, and the gliders didn't fly so well, so they started thinking there might be something wrong with these tables. We might need some more information, and that's what this experiment did. They built these plates, and this one creates lift and rotates the wheel this way. So what they were doing was recreating the experiment by Otto Lilienthal to measure or balance the drag of the flat plate and the lift of the curved surface. And looking at those tables, it was all on the angle that this curved surface was set at. Tables told them, set it at 5 degrees, angle of attack. It's a very important angle.
That's another math
yes,
aspect.
and the angle of attack is the angle where the wind meets the wing. So if it's flying level, it's 0 angle of attack. If you're flying straight up, it's 90. So they thought that at 5 degrees angle of attack, they'll balance. The wheel won't rotate. It'll hold steady. Well, it didn't. It swung around. And that told them that there was something wrong. So they started increasing the angle of attack, and it wasn't until 18 degrees that it finally came to rest. And that's when they knew they had to get more information.
So what did they do to get more information?
Well, like I said before, you have to imagine them riding down the street, and just as you do today, you have to dodge the potholes and everything else. So they needed an experiment that they could reproduce and run the same test over and over and over with different shaped wings. And so they built a wind tunnel.
Oh, a wind tunnel.
Yes.
You know, we have some video of a wind tunnel that may help explain what it is.
That's exactly it. Well, what you see there is a little balance that they built inside a wooden box with a fan at one end, and the air flows through the box and flows over a little curved surface, just like I have here on the bike, and some flat plates, also like I have here on the bike. And when you take the paddle away, the air hits the balance and it rotates. If you block off the air to the drag plates, it'll rotate the other way. And with this simple machine, the Wright brothers were able to build over 200 different wings. And they tried all sorts of different shapes, different sizes, different curves, and they started learning what makes a wing work.
Okay, and what makes a wing work, they found out, was aspect ratio. Margie?
Yes. Aspect ratio is one of the things about a wing, and I brought a couple of plans to help me explain aspect ratio. So I've got two planes here, and these have the identical size wings. They look just the same to you, don't they, Kate?
Yes, they do. Well, one's long and skinny, and other one's short and fat.
Right. One's long and skinny, one's short and fat. This wing is 8 inches long by 1 inch wide. So if I take length times width, I get 8 square inches. This one is 4 inches long by 2 inches wide. 4 times 2, 8 square inches. So they're the same size wing. So people thought they'd lift the same. But the Wright brothers discovered, no, they don't. Because if I take 8 and divide it by 1, I get 8. If I take 4 and divide it by 2, I get 2. So the aspect ratio, that division problem, the answer is 8. The answer is 2. High aspect ratio in slow-speed aircraft is going to provide more lift than a low aspect ratio.
So the Wright brothers knew that they were given the tables about how big the wing had to be, but the Wright brothers figured out it had to be long and skinny instead of short and fat.
That's exactly right.
And this information led directly to their success in 1903, didn't it? And further success in 1905.
Oh, it absolutely did. When they finished these tests, they built another glider that had the same surface area as their previous glider, but it flew 10 times better.
Okay.
And not only, so with the success of that glider, they could build a powered airplane, and with a powered airplane, they needed propellers, and the wind tunnel data worked for the propellers. It worked for all of the airplanes they ever built.
All right. Well, thank you very much, Paul, for being with us.
My pleasure.